The product of two positive integers is 546. If the first integer is 11 greater than twice the second integer, what is the smaller of the two integers? Okay, now let me assume x and y as the two integers. Let me write it over here. Okay, according to the first information, the product of the two integers equals to 546. That is x times y equals to 546. Okay, now in this equation, I'm going to solve for one of the variables, either for x or y. Okay, let me solve for y. Then I have to get rid of the x, which is multiplied over here. For that, I have to divide both sides by x. When I divide both sides by x, this x will cancel. I'm getting y equals to 546 over x, and I assume this is equation number 1. Okay, now let me consider the second information. That is, the first integer is 11 greater than twice the second integer. So we can assume x as a first integer. Then it is equal to 11 greater than twice the second integer y. That is, that can be written as 2y positive 11. Okay, now to solve for x and y, what we can do is we can plug in this 546 over x for y over here. Because already we have solved for y in terms of x, so the stuff which is equivalent to y is 546 over x. That we can plug in for y into the equation we have over here. Then I'm getting x equals to 2 times 546 over x positive 11. Okay, then we get x equals to, when I multiply this 2 and 546, I'm getting 1092 over x positive 11. Okay, to get rid of the denominator x over here, I'm going to multiply both sides of the equation by x. So x times x equals to x times 1092 over x positive 11. So x times x is x square equals to, when I distribute this x to this one, I'm getting x times 1092 over x. When I distribute this x to this positive 11, it will become positive 11x. So this x will cancel out. I'm getting x square equals to 1092 positive 11x. Okay, now it's a quadratic equation in the variable x. So to solve this quadratic equation, we have to get this quadratic equation in standard form. That is ax square positive bx positive c equals to 0. Okay, so for that we have to get everything on the left side, and the right side must be 0. So what I need to do is I have to get rid of the two terms over here on the right side, so that I'll have 0. So let me subtract 1092 and 11x from both sides. Let me do it. Okay, when I do such a subtraction, this positive 11x, negative 11x will cancel, and the same thing here. Then I'm getting x square negative 11x and negative 1092 equals to 0. Okay, now I got the equation, quadratic equation in standard form. So that is x square negative 11x negative 1092 equals to 0. Okay, now we have to solve this quadratic equation for x. I think it's a bit difficult to solve by factoring, because the number over here is a little huge. So since it's a digital SAT, we can use Desmos graphing calculator to solve this quadratic equation. Okay, so here I am going to use the quadratic formula to solve this quadratic equation. So for that, the quadratic equation over here has to be compared with ax square positive bx positive c equals to 0, so that I can get the values of a, b, and c. So here is the coefficient of x square. Here the coefficient of x square is 1, so the value of a is 1, and b is the coefficient of x. In our problem, it's negative 11, and c is a constant term, that is negative 1092 over here. So now let me write the quadratic formula, that is negative b positive or negative square root of b square negative 4ac over 2a. Okay, now let me plug in the required values over here. Negative of negative 11 positive or negative square root of b square means like negative 11 the whole square. Negative 4 times the value of a is 1. The value of c is negative 1092 over 2a. 2a means 2 times 1. Okay, now I'm getting x equals to negative times negative will become positive 11. Positive or negative square root of, so 11 square is 121. So when I multiply this negative 4 times 1 is negative 4. Now when I multiply negative 4 and negative 1092, I am getting positive 4368 over 2 times 1 is 2. Then I'm getting x equals to 11 positive or negative. So when I add 121 and 4368, I'm getting 4489 over 2. Okay, let me erase the other stuff and continue this one. This is the last step we have added in our previous working. Okay, now let me continue. So 11 positive or negative, and when I find the square root of 4489 using calculator, I'm getting 67 over 2. So now we can split up the solution into two parts. One we can write for positive sign over here, and the other one we can write for negative sign over here. Then I'm getting 11 positive 67 over 2, 11 negative 67 over 2. So when I add 11 and 67, I'm getting 78 over 2. And here, so when I simplify this 11, negative 67, I'm getting negative 56 over 2. X equals to, when I divide 78 by 2, I'm getting 39. When I divide negative 56 by 2, I'm getting negative 28. Okay, so here x and y refers to the two integers mentioned in the question. The question clearly says two positive integers. So since x and y refers to the two positive integers, the value of x has to be positive. So we can ignore the negative value of x over here. So we get x equals to 39. So now I got the value of one of the integers. Okay, to get the value of the second integer, what I need to do is I have to plug in x equals to 39 into the first equation over here so that I can get the value of y that represents the second integer. So to get the value of y, so I have to plug in x equals to 39 over here, 546 over 39. So when I divide 546 by 39, I am getting 14. So I got x equals to 39 and y equals to 14. So now I got the values of the two integers 39 and 14, but we have to find the smaller of the two integers. So among these two integers, the smaller one is 14. We find 14 in option B. So the correct answer choice for this question is option B.